This video is about stainless steel processing precautions. If you also think the video is good, you can praise and subscribe to our channel. Featuring corrosion resistance and high temperature resistance, the stainless steel is used to manufacture various products that we can see in our daily life. As an alloy material, the stainless steel has different crystalline phases which changes correspondingly as the temperature changes. So what needs the operator's attention during stainless steel machining? 1. Machining area. The machining region for stainless steel parts should remain relatively unchanged and the platform in it should be quarantined by covering with a rubber blanket or something else. Fixed location management and civic production should be enhanced for the machining region for stainless steel parts, so as to prevent them from being damaged and contaminated. 2. Cutter material selection. Because of large cutting forces and high cutting temperatures during stainless steel part machining, a hard alloy with high strength and good thermal conductivity should be chosen as the material for cutters. The rake face requires a small roughness value for cutter sharpening. In order to avoid cuttings sticking to the blade, cutter sharpening should be performed carefully for both the rake and flank faces to guarantee a small roughness value, reducing the cutting's outflow resistance. 3. Cutting fluid selection. Since the stainless steel features a high tendency of adherence and low heat dissipation, it is very important to choose a cutting fluid with high adherence resistance and high heat dissipation during boring. 4. Blanking. Shearing, sawing or plasma cutting is used for the blanking of a stainless steel component. 1. Shearing. During shearing, isolation should be performed between the component and the feed-in holder, and a rubber cushion should be used for the material hopper to avoid scratches. 2. Plasma cutting. Cutting residues should be completely removed after plasma cutting. During batch cutting, the finished components should be moved out of the site in time, to avoid being tarnished by cutting residues. 3. Sawing. During sawing, the fixture should be protected with rubber. The workpiece after sawing should be cleared of oil, dirt and residues. 5. Machining. The stainless steel parts should be protected during machining like milling and turning and should be cleared of oil, dirt, residues and others after operation. V-shaping. During plate rolling and bending, effective measures should be taken to prevent the stainless steel components from surface scratches and bending marks. 7. Rivet. Welding. During stainless steel component coupling, forced assembly should be avoided, especially the flame grilled assembly. When plasma cutting is temporarily used, during coupling or fabrication, isolation measures should be taken to prevent cutting residues from contaminating other stainless steel components. After cutting, the workpiece should be clear of cutting residues. 8. Welding. Before welding, the stainless steel parts must be carefully cleaned and cleared of oil, dirt, rusts, dusts and other things. Argon arc welding is always preferred. When manual arc welding is performed, low currents and rapid welding should be used, to avoid swinging. No arc strike is allowed in the non-welding region. The ground electrode should be in a proper place and firm connection to avoid arc scratches. During welding, anti-splashing measures should be taken, such as brushing with lime. After welding, the slags and splashes should be completely removed with a stainless steel flat spade, carbon steel not allowed.